So before I get started here talking about assigning values, I'm going to go ahead and open up the solution that I created under section 1 for our class in GitHub. And as you can see, there is an example for each of the topics in the section, all culminating up to the total information that you need to know to be able to complete the assignment 1. So I want to just show you what this solution looks like. And there's actually a couple of things from declaring variables that I forgot to tell you about in the last video that I will show you now really quick. If this thing ever opens. So my solution has 5 projects in it. And actually, one thing I noticed about Visual Studio 2015 is that if you click on any aspect of the project, it automatically makes that the current project. So when you run the program, it'll run whatever program you have selected. So if I highlight this, it's going to run that program. If I highlight this, it's going to run that program. I think in earlier versions of Visual Studio, whoa, that's a lot of code. Let me just close this for a second. In earlier versions of Visual Studio, if you have multiple projects in a solution, you have to like right-click and say, you have to highlight the project and right-click it and say, set as startup project, but don't have to do that here. So before we start, let me really quick show you what I had for example 1, declaring variables. As you can see, there's a lot of comments and not a whole lot of code. There's a string declaration, there's an integer declaration, a float, a long, a double, a bool, and I do have a link here also to the complete list of types in Visual Studio. So that's nice. What were the things that I wanted to say? Oh, right. So there are 2 things that I forgot to mention in the last video. The first is that you might have noticed me using a lowercase letter at the beginning of the variable name and then uppercase letters for all subsequent words. And we call that's really just a convention. It's called camel case. I guess because this is like the head of the camel, and then it's got like a hump there and a hump there. Anyway, they call that camel casing. And that's usually what people use in C# for variable names. And there was another thing that I wanted to say. Oh, right, case sensitivity. So C# is a case sensitive language. So for example, if I wanted to make another variable called is door closed with a capital I, this is 2 different variables. That's totally fine. You can't have 2 variables with the same name, but if you change the casing of the variable name, then it's different. And that's important because you're going to declare a variable like this, and then later on you'll try to use it, and you'll accidentally like make the L uppercase or something, and it won't work. So you can fix that by doing a lot of copying and pasting to make sure you don't misspell things. So I just wanted to mention that C# is case sensitive, and also that you don't really have to use this camel case convention, but that's how a lot of people do it. So moving on to assigning values. I'm going to start off by showing you what I have in the example code, and then I'll mess around with just some freestyle code. So here I have, let me just read through this. Here are some examples of declaring simple variables and assigning values. So in the past we've declared variables, but we never assigned values. I've shown some invalid as well as correct value assignments. So this guy here, equals. Now we're not going to get to operators until next time, but I can't avoid introducing the assignment operator. So this is the assignment operator, which is the equal sign, is a part of the C# language, and that is how you assign values. You use the equal sign. So as you can see here, you declare the variable, as we saw before, and this is how you assign a value, by using the equals operator. So I'll get into the details of that syntax in a second. So when you see the single equals sign, that is called the assignment operator. It's not the equal sign, it's the assignment operator. This is how C# places a value into a variable. So that's the whole thing we're talking about here, is taking a value and actually setting a variable to hold a specific value. Now we can change that as many times as we want, but at any given point in time, a variable contains a certain value. Now this is important. The type of the value that we put in the variable must match the type of the variable declaration. We talked about that before. If you declare the variable as a string, it must contain a string value. Every time you assign a value, it completely replaces the previous value. So if I say int x equals, or if I say int x and then I say x equals 5, and then I say x equals 10, well, first it's going to declare the variable, then it's going to stuff a 5 into the variable, and then the very next thing it's going to do is going to stuff a 10 in and completely blow away the 5. So after these 3 lines of code execute, you will have a variable of type int named x with the value of 10. So I'm going to do some freeform code, but before we do that, let's just blow through these examples here. So I've shown a string declaration, which we did in the previous lecture, and I've put a comment after every instruction to kind of describe what it does. And I've shown some correct and incorrect examples. So first thing is, with strings, you have to put a double quotes in front of and in back of a string literal value. So the value of a string has to be within double quotes. I'm not really sure how else I can say it, but no matter how many times I teach this, it always confuses people, because it's kind of hard to think about what's the difference between a string and what's the difference between a variable name. So when when the language sees a word like team name that doesn't have quotes around it, it tries to find a meaning for that word. But when it sees something with quotes around it, it doesn't try to find a meaning. It knows that that is a literal string. So it's quite simply the character capital C followed by the character L followed by the character E. It's not trying to do anything other than treat it as a literal string. So this is correct, because the assignment operator, the equal sign, the way it works is it takes a value on the right and it puts it into the variable on the left. So anytime you see the assignment operator single equal sign being used, you want to look to the right of it and you want to look to the left of it, and you want to make sure the types are the same. So as I look over here to the right of it, I say, oh, well, there's a double quotes, and it doesn't matter what's inside of it, because anything inside of double quotes is a string. So this is a string on the right, and then on the left I have a variable name, and that variable is declared here as a string. So basically I'm saying this variable, which is a string, is given this value, which is a string. Since on both sides of the assignment operator we have a string, this is a valid statement, and that's why I have no errors. So that'll work just fine. This guy here, team name, equals C. In this case, I also said equals Cleveland Indians, but I just said Cleveland space Indians. So, I see a lot of first semester students doing this because, it takes a few minutes, and by minutes I mean like sometimes months and years, to kind of figure out how the compiler is looking at this stuff and thinking about it. So, it's parsing through this stuff, and this first line of code, it clearly sees the syntactical phrase of type name semicolon, which means variable declaration. Anytime you see a type and then some unused symbol and a semicolon, this is a variable declaration, and it can understand that. Now the next line, the first thing that you're doing is you're specifying a variable name, team name, followed by the assignment operator. And the moment that the compiler sees that, it says, oh, I know what team name is. It's a variable that's already been declared. And since the assignment operator is following it, you must be trying to assign a value into this variable. Well, since the declared type of team name was string, then I'm expecting a string value on the right side of the assignment operator. Unfortunately, Cleveland is not a variable that we declared. If there was a string up here that was named Cleveland, we might not have a problem, or at least not the same problem. And I'm expecting that if I hover over the word Cleveland and look at that error there, it's going to say, hey, you didn't define any variable called Cleveland with the type string. And it says the name Cleveland does not exist in the current context. So, long story short is I have to have a string over here on the right side of the assignment operator. You can't put anything inside of this variable unless it's a string. So that doesn't make any sense. There's nothing. Cleveland has no meaning in this context. Indians has no meaning in this context. But anything you put inside of a double quotes is a string. So if I get rid of that line right there, should be okay. Now it's just going to complain that I probably never used the thing. The variable team name is assigned to you, but its value is never used. Well, that's just a warning. The green lines are just warnings. We don't really care about those. So on to the next example, I have another variable declaration, and this time it's an integer. So hopefully this one should be pretty straightforward. We can see that the value on the right side has to be an integer. 40.5 is not an integer, it's a double, and 40 in quotes is not an integer, it's a string. So these are all literal values. That's a literal integer, that's a literal double, and that's a literal string. But since number of players was declared as an integer, the only line here that's a valid line of code is that one. So then on to the third example, I have long, which is pretty much the same thing as an integer, except it has more memory, can hold bigger numbers. So same thing. You can't put a string in there, you can't put a decimal in there. It has to be an integer. So float. A float is a decimal, so we cannot put a string into a float. And this one's actually kind of strange because when you say .333, and that's a decimal, there's two types of decimals in the C# language, a double and a float. So a float is a normal old decimal, and a double is a bigger decimal. And double stands for double precision. So you can store a number with a much longer series of decimal places. And by default, if you just type in a literal decimal like this literal value is treated like a double. So the way you can say, actually, I just want to treat this like a float instead of a double is by putting this little f afterwards. It's really weird, but that's the way it is in C#. Whereas this one down here, you can't put .666, the string, inside of a double, but you can put that decimal in just fine. So these two are exactly the same. They're both numbers. The only difference is this one's a float and this one's a double precision. So with the float, if you wanted to avoid that compiler error, you have to put the lowercase f after the literal. So if you look at all these examples that we just looked at, there's a literal string, there's a literal integer, there's a literal long, there's a literal float, there's a literal double. And then the last one here is going to be a bool. So this variable is named isDoorClosed. It's of type bool. Now bool types can only have two possible values, true or false. And as you can see down here, those values are actually blue, which means they're keywords that the language recognizes. The language recognizes that true is an actual literal value. So we can't put a string in there. You can't have a capital T. It has to be exactly lowercase t, lowercase r, lowercase u, lowercase e. You can't say yes. None of this is going to work. It has to be exactly one of these two. So true or false. So I'm going to get rid of that one just so we can see one example. So now all of our cases, all of our situations here with the types that we're ever going to use in this class, string, int, long, float, double, bool, we can see that we've declared them, and in the very next line we've given them a value. And once again, you can change the value at any time by saying, in the very next line of code you can give it another value. And remember, the instructions go one at a time, top to bottom. So I'm actually going to run this and step through it when we get to the end here, so that you can see it running and see the values changing. I'll leave that one in here too, so you can see that changing as it gets hit. But the moral of this story is you can directly after you declare a variable, you can give it a value, and then you can change your mind and give it another value. And this process is called value assignment. And once again, just to reiterate it because it's the most important point of this, the way you assign a value to a variable is by using the equal sign, which is known as the assignment operator. Assignment operator takes the value on the right, puts it into the variable on the left. And of course you need your semicolon. So this is the syntax of an assignment, just like this is the syntax of a variable declaration. So that is that. So coming down and learning some other interesting things. If you wish to make your code a little more concise, you can combine the variable declaration and the value assignment into one line of code. This is called a compound statement, since one line of code is performing multiple instructions. This is a very common thing to do in C# programming. So in the past, I was declaring the variable on one line, and on the very next line, I was giving it a value. You can actually do both of them in the same line of code, like this. String my name equals Donnie, instead of saying string x, and then saying x equals 5, you just say, oops, instead of saying int x and then x equals 5, you can do it in one line of code, int x equals 5. So this is much more common. You're going to see that a lot more often than you see. People don't really declare a variable and not give it a value unless it's necessary. So this is going to be more common. But when you're teaching it, it's important to start off with this so you can see the difference between the instruction and the syntax of the two different instructions. You want to know the syntax of a variable declaration. You need to know the syntax of a value assignment of that variable. And once you have those mastered, you can combine them into a compound statement like this, and that'll clean up your code a lot. So that's just two examples of a variable declaration plus a value assignment using a compound statement. I think I already talked about this, but another important thing to note is that there are multiple kinds of values. The simplest kind of value is called a literal. So I've kind of been talking about this without really explaining it because I thought it was obvious, but a literal is anything that is a value that is explicit, like 190. There's no ambiguity there. It's the number 190. There's nothing ambiguous about the string Donnie. It's the string Donnie. That's all there is to it. Those types of values are called literals. And you might say to yourself, well, what kinds of values aren't literals? Well, a variable, which we've been learning how to declare and assign values to, is a container for a value, but a variable is not a literal. This is because variable value is not known until it is examined in memory. So this is the point. I can look at this. My program is not running right now. I'm just looking at the code. We call this compile time or pre-runtime. Compile time is when you have not yet run the program. Runtime is while the program is running. So before runtime or at compile time, I know that this value is, or this variable is going to have the value Donnie. I know that this variable is going to have the value 190. The reason I know those things is because I'm using literal values. So there's no question what those values are going to be there. However, if I look at this line right here, and I ask myself, okay, I have this variable highest score, it's going to be given the value of my score. Well, what is that going to be? And the answer is, well, I'm not sure. It depends on what value is inside of the my score variable. So this is not a literal value, this is a variable value. And obviously right above it, we have defined another variable called my score. So there's two variables here, my score and your score. So maybe we're playing a game together, and we wanted to see whatever the highest score was, we wanted to put that score into the highest score. So if you visualize this, these two variables are going to exist in memory at this point right here on line 55. And my score is going to contain you think of variables as like these little boxes that have values in them. So my score is going to contain the value of 99. Your score is going to contain the value of 86. And then right here, it's going to say, okay, I'm declaring this integer high score, and I'm assigning it the value of whatever is in the variable my score. So at that point, what it's going to do is first it's going to examine the validity of the statement. It's going to say, okay, the assignment operator is being used. The variable on the left is declared as an integer. Therefore, the value that is being assigned into that variable on the right better also be an integer. So it's going to look at my score and say, are you a valid value to be put into this variable? You must be an integer because highest score is an integer. And as we can see in the definition, or in the declaration, my score is indeed an integer. So the first thing the compiler does is say, okay, everything's fine, I'm trying to put an integer into an integer. The second thing it has to do is actually look inside of this variable and say, well, what's the value? It will go there into the little box, which is my score, the variable, and it will find the number 99. It's going to take that number 99 and make a copy of that and put that value into highest score. So at the end of these three lines, 53, 54, 55, we're going to have three variables here, and the number 99 is going to be in this one, the number 86 is going to be in that one, and the number 99 is going to be in highest score. So it sounds, I'm kind of talking about it for a really long time, even though it's simple, just because like I said, I did this slew of C# lectures before where I just assumed that everything was obvious, and this time I'm trying to be more verbose about it. So, and what did I say here at the bottom? So notice that we assigned the variable highest score the value of my score. My score is a variable of type int, which means that it contains an integer value. It's not a literal because we don't know the value until the program runs. Alright, so I'm just explaining here that variables, you don't know what the value of variables are going to be until runtime. And that's the difference between a literal and a variable. So that's all of this. I think I can actually run this now. Let's do this. I'm going to put a breakpoint right there on line 17. And I'm going to hit F5 to run this thing. Waiting, waiting, waiting. Okay, so now my breakpoint hit, and as you can see, I'm actually going to make this locals window a little bigger down here until I can see all my variables. Whoa, don't do that. There we go. I want to be able to see them all. So you can see, even though I'm kind of way up here, it already looked forward and preemptively declared all of the variables that I'm going to declare in the main program here with default values. Well, this is good because the purpose here is to watch them being assigned values. So now I go back and I notice that there's these little arrows up here, step over and step into. So for now, the only one we care about is F10, step into, or sorry, step over. So you can either click that little arrow or you can use F10. I'm going to go ahead and click the arrow just because you're watching and you can't see me hitting F10 on my keyboard. So let me say really quick though that when this line is highlighted in yellow, it means I'm waiting on that line and have not executed this instruction yet. So team name equals Cleveland Indians has not been executed yet, as clearly can be seen by the value of team name right here. Team name is still null in our values in memory. So when I come up here and I click step over, now the highlighted line of code is line 18, which means line 17 just got executed, and clearly down in my locals I can see team name value has been given the string value of Cleveland Indians. So if I come over here and I click my arrow for step over again, it's going to next execute line 18, which is going to overwrite the value that I just put in team name of Cleveland Indians with Cleveland Browns. So if you keep an eye on the locals down there, when I step over it, Cleveland Indians just got switched to Cleveland Browns. Now I'm about to execute line 21. I expect to see my number of players on team to be given the value of 40, and that should show in red in my locals, and it does. Some huge integer is going to be given the value of 1 hojillion or whatever that number is, and it did. Team batting average is going to be given the value of 0.333F. Team slugging average is going to be given the value of 0.666. Is door closed is going to be given the value of true. My name is going to be given the value of Donnie. My weight is going to be given the value of 190. My score is going to be given the value of 99. Your score 86. And now, this is interesting because I also want to show you that you can kind of hover over these variables to see what they are. So I'm about to execute line 55. I'm debugging my code. I'm looking at this. I'm saying, okay, I'm on line 55. I'm about to execute it. I'm about to put whatever value is in my score into this other variable, highest score. Well, I could say to myself, well, what's in my score? And maybe I don't have the locals window open, so I can just hover over it and it'll show me right there. You can hover over anything and it'll show you the values of it anywhere. So right now, highest score is 0 because I have not executed line 55 yet. But as soon as I execute, and now it's on the end of the program, but I can see now highest score is 99, both there and in my locals window. And that should be the program is over. So that is value assignment. I think I covered everything that I wanted to. Pretty much. The next, I think, anything that I missed, I'll think about it for a little bit before I do the next video, because the next one is going to be probably the longest and toughest one out of the first section, which is operators and expressions. It's pretty simple to declare variables and give them values, but the operators and stuff can be a little more tedious. It's a little more information to digest. So I'll go ahead and end this one here, and like I said, I'll think about it, and if I missed anything, I'll get to it in the next one. But hopefully this should be pretty straightforward for you, understanding how to declare variables and how to give them values, and what the difference is between a literal value and a variable. And just as a kind of like a sanity check, actually I don't need to do incognito. My GitHub, so keep in mind that my GitHub for this class is IT1050, and I have links to all this in Blackboard over here, which I'm currently constructing. As you can see down here in code examples, I have direct links to GitHub. But even if you don't have, those links in front of you, you can always just go to github.com/DonnieSantos, click on the IT1050 repository, and right now I'm creating the material for section 1. So section 1 has the entire solution in it, and you can download the whole thing by going to the repository and clicking download zip. Or you can just peruse it in your browser here. Like if you want to look at the code that we were just looking at in the browser, come into assigning values, you go and click on program.cs. And there it is. There's everything that we were just looking at. So I just wanted to remind you that the YouTube stuff that I'm doing now and the GitHub stuff that's there for you are supposed to be working in tandem. They're supposed to be complementary in nature. So keep that in mind, and make sure that you're solid on the first 2 videos, which were declaring variables and assigning values, before you move on to operators, because if there's anything that's not clear at that point, you probably want to get that resolved before you move on. All right.